Hey, hello everyone. Hope you guys can hear me. Welcome back to my stream. Today I'm gonna try and build a Twitter-like system, Twitter or X.com, you may call it. So first of all, like always, I'm gonna first list out the system requirements and then go to the non-functional requirements. No, sorry, what I meant by functional requirements and non-functional requirements. And from there on, I'm gonna do some estimations, and after estimations, we're gonna do a high-level system design, and then gonna dive into details of that design. So let's just get started. Um, so what are the functional requirements going to be? So basically, we want Twitter. If you see at the core, Twitter has some functionalities like following, or posting a tweet, and viewing the timeline. This is going to be very similar to how we did the system design for Instagram, because Instagram also kind of have the same level of functionality. We can post an image, we can follow each other, people can view timeline. It's pretty much the same thing. If you understand how to build an Instagram like system, you'll pretty much understand how to build a system like Twitter. Yeah, so let's get started. So I'll list down the functional requirements as um, following a user and unfollowing user. Let's add some more stuff into it. Follow and unfollow. And next going to be post a tweet, and at last view timeline. Okay, so these are going to be the functional requirements. Now let's get into the non-functional requirements. So before going into the non-functional requirements, we may need to understand how much users we're gonna need, how much storage data we need, all those kind of things. So for our sakes, let's say we'll have um, 200 million daily active users on Twitter. Okay, daily active users, and out of these, we need to kind of understand how many people post a tweet, and yeah, so that, and how many like just read. So everyone's gonna just read tweets, right? And But not everyone's gonna post a tweet. So it's gonna be majority of the time it's less people posting content than people actually consume the content. So we could call it like 10% of uh, the overall users would post a tweet. So that will be like what, 20 million users posting a content, right? So 20 million daily active users, and about 10% posts a tweet. Um, Instead of um, like generalizing like 20 million posts a tweet, I think it'll be much better if we can come up with an estimation of uh, like how many uh, how much tweets a person makes on average. We can call it like a 10, a person makes at least uh, 10 posts a day. Okay, I think that will give us more accurate information if you can like get into the granularity of this. So it's when it comes to estimations, you don't have to go into granularity, but it's always better to get into like specific numbers. um, so it will be much easier to build upon that in terms of scaling and data requirements, all those things. So say a person makes 10 posts a day, and can we say a person consumes about 100 posts a day. So we have 10 million daily active users, and a person makes about 10 posts a day, and um, a person consumes about 100 posts a day. And like I said before, not everyone posts. Everyone posts tweets. Most of the people consume content instead of creating content. So when you think about these things, it's already kind of makes sense. These kind of systems will have more reads than writes, basically. So here, if a person makes 10 posts a day, we'll have 10 writes, but at the same time, the person consumes 100 posts a day, which is more reads. So these kind of information gives us to like kind of come up with an estimation, right? And given this information, we also need to know what are we going to like store and what kind of data we're going to store. So when it comes to a tweet, it'll be mostly characters. About I think it's 280 characters per tweet. um, in a basic level. And right now Twitter has a subscription model. If you subscribe, you can post more characters, but let's not go into that. At a basic level, Twitter you can post about 250 characters per post, I believe. So uh, let's kind of come up with database schema design too. That way we can kind of uh, have more things we can estimate for. you know so this basically tells us we're gonna have more reads than writes. And now let's go into the database design. And let's say, oh, do we already have like table time thing? No, it's different. You don't need a swim lane here. Let's get a text box and just say uh, so let's go from the first requirement. We need to know follow and unfollow, and before that we need to have a user table, right? Users table. And this users table is gonna have probably the user ID, which may be the handle, unique handle. And what else? We can maybe have a created at, account creation date. I mean, probably not required, but I'm just gonna keep it there. Email address. Yeah, let's keep it as keep them for now. So we're gonna have a user ID, and yeah, so that's gonna tie most of those things. So that's gonna be the users table. And let's also have a tweets table. Okay, so that's gonna have a Twitter tweet ID, and the content. For now, I'm just gonna talk about the text being the content. Uh, you can obviously add video content and image content on Twitter too. We'll come to that. Let's see how our time goes, and I'll circle back to that. But for now, let's only worry about number of characters. We just store 250 characters white content. That's about it. And then we need the user ID. And we can also have some more like metadata, like likes, views, and also have like retweets, all those things. But for now, I'm just gonna keep it simple. And let's keep it this. And next, next, when you talk about follow and unfollow, we need to know who follows, who's following who. So let's say followers table. Did I spell it right? Yeah. So we'll have a ID for a primary key, and um, uh, let's call it follower, and follower ID, and followed by ID, and followed by ID. Okay. Oh, I'm using different cases here. We go back and fix that. Okay, so this is gonna have the followers, and what else do we need? We also need to have like a timeline, right? So when you think about it, we're gonna have to kind of do multiple joins here, right? When you try to build a timeline, basically, I'll just give a high level overview before I go into details. So basically, if you try to build a timeline, you have the user ID, and you will go and query all the um, for user this user follows, right? So you'll go and grab all the people this user follow using this table, and then grab all the tweets using that ID. You have the user ID here, and get all the tweet ID, tweet content, and aggregate all of them and return it, right? So that's how we're gonna build this timeline, but I'll go into more details as I cover that section. So given all this information, we know we're gonna have like more writes, and sorry, more reads and then more writes. um, I We need to have a way for it's in terms of thinking of database, it's better to have a read write replica kind of structure, but let's go into details when you get there. So for the thing, I'm thinking, what estimations do we need to make? um, mm, so we have 20 million daily active users, and we make about 10 each person. Let's say let's just round things up, and let's say uh, we need like 10 posts a day. Each person makes 10 posts a day, so that's about what is that, 2 billion, uh, 2 billion posts a day. So when you scale it up, you have to store like 2 billion posts a day, and you're gonna have 2 billion writes per day. So we need like really high throughput, and at the same time, if you think about this is like what, um, 20 billion uh, post reads per day, right? So this is going to be like huge amount of data that's gonna um, we need to support. And when you think about in terms of the API should be able to handle say like uh, man, like thousands of requests per second, um, and it should be able to scale as well, right? So that's how much load we need to handle here. So let's see, when you talk, let's talk about the APIs. Let's go ahead and design the APIs. So what are the APIs do we need? Let's think about follow and unfollow. For following and unfollowing, uh, so to follow, we need to make a post request, or a put request. Let's say put request, we'll have the user ID. We'll make a put request to like API slash follow, and we'll this could have the user ID, and the person following. So for example, if you want to make a, I'm thinking if you which one is better, creating a request body or just putting it in the API itself like a query parameter. Hmm. I'm just thinking if making it a post request body, is it a overkill? Do we really need to make it do that, or just have it a like a put request and be done with it? Hmm. I'd say let's um, make it a query parameter here, follow, and maybe pass the uh, user ID here, and the user ID the follower ID. Okay, so we'll post the follower ID here, and in the header I would say we'll pass the user ID. So header will have something like user ID, the current user ID, and it will have the user ID. Okay, I think this is better. And um, in the header we can also have auth token that get passed. So let's say we have I mean, we'll obviously have an authentication system which generates a token for the user when they signed in, and we also pass the auth token in this one, so the downstream system, I mean the API server, know the user is authenticated, and they'll have the user ID at the path param, and they can grab it and update it. So once they follow the, you talk about the response, we'll say a 200 okay, and if anything goes wrong, let's say there's a bad request, there is something missing here, anything in the request, we'll just say 400 bad request. And if the auth token is missing, we can say 401 or 403. I think 403 is better. Let me just make sure. 401 and 403, which one is appropriate here? Okay, that's forbidden. 401 is unauthorized. I think for this case, it's unauthorized is much better than much better fits here better than 403. So 401 unauthorized, and if something goes bad in the server, we'll say 500 server error, and yeah. So this is just in high level. As we build things, we'll come up with more use cases, and we may need to have better way to tell the client what happened and how the client should react based on it. So for this information, I think this should be good enough. So that's to follow. How about unfollow? I think we can make a delete request here, and just give the follower ID with the delete, and the same thing for the header, and it's a same response should be good enough here. Okay, come on, not helping here. And how do I get rid of this? Oh well. There we go. Okay, so this should be good enough for this follow and follower APIs. And let's go into the posting an tweet API. So posting a tweet. So that's, I think it's more appropriate to have a post request here. So let's say API. mm, let's just say post tweet. Okay, and here we'll have a request body. And what are we gonna have in the request body? In the request body, we'll obviously have the content. Maybe the created at. So we generate the created at the client side itself, uh, and give it, pass it down to the downstream systems. Um, and yeah, and the header, I would say this header is much better for this case too. User ID and auth token, and the same response is good enough for now. To when the if the post is successfully saved in the database, we'll get a 200. Something's missing, we'll get a bad request. Let's say if we send one of these is not there, let's say this is both are required fields and both of them are missing, or one of them is missing, we'll send a 400 bad request. If the auth token is missing or expired, 401 or something else goes 500. So this API should be good enough. And let's also talk about the view timeline API, and let's just go into detail and how we gonna design that. Well, I think it's more appropriate once we go into the design and set up the high level design. It'll be much more clear why I did certain things in certain ways. So I'll come back to the timeline thing after I go into the design phase of it. Okay, so with these things, with this information, let's go ahead and design the system in a very high level. So we'll have a user, or not talk about user. Let's have the client. It could be a mobile or web application, web or mobile, and it's going to interact with some kind of a API gateway. Okay, I'm not going to go into how the authorization is going to work, how we generate token, all those things. Let's just focus on, let's assume the authorization part is done. We'll cover that, how auth could work and how authorization system design is built on a later video. But for now, let's just say we have an authentication system and it gives a token and we are always good. So we'll have a API gateway here. Before I go into the API gateway, let's just think about the very high level system. What are the components that we're going to need, like the core components? So web mobile application, that's out of our reach. We're just building the backend system. So we'll have an API server in the backend, which gonna have these endpoints exposed and serve it to the mobile application, basically. And this API server is gonna talk to a database to pull and save data. That's all. This is all we need in a high level. If you're building for like very few users, all you need is this. But we are talking about 2 billion posts a day and 20 billion posts reads per day, right? So this is not gonna cut it. So one thing always like all large systems have is a API gateway at the front. So what this gateway does is basically takes the request and it basically sits in front of the client side and the backend systems. So it's going to take the request and send it to the appropriate service basically, and act as a load balancer as well. Okay, so this API gateway is its own scaled up system, can have multiple services running behind it, and have its own load balancer to balance the requests, and it's kind of managed on its own. And the API gateway comes in like different flavors. It could be a REST API, basically it exposes basically a REST API to the client side, or it could be a GraphQL API to exposes a GraphQL query to the UI, and the UI query is only the things that it needs. and also GraphQL has mutations too, can make post request back to the server. So and that's what the API gateway does too. When a client asks something, it just routes to its correct server basically. So that's it. API gateway is here, and we have our backend server, and the request comes to the database and serves everything, right? But it's obvious we have like a single point of failure here, right? If we have one server and if it goes down, we are done with it, right? So we should definitely have a server that's scalable, have multiple instances of the server, and the API gateway basically knows, like, basically routes. I mean, does the load balancing and routes the requests to each of the instances. And it's always good to have these instances stateless basically, as much as possible. Most of these services, microservices, when you think about microservices, those are always stateless. And another important thing, I mean, some people, like, when they're trying to build a large scale system, they just think about microservices. In my opinion, microservices only need to be built only when you need to build it. I've done that mistake before too. Build systems before when we don't even need a microservices. I thought that's the way to go, and broke all the components into microservices and built it. But that's not the way to do it. It's usually better to build microservices, in my opinion, like as we go, like as the system evolves, in a production setting, right? And let's say you are building in like a brand new application. You don't know how much the user is going to need. I mean, when you build a brand new product, basically, right, you may have like a very small set of customers, maybe like a 50 or maybe even 100 customers, right, who's going to use the application. And for that amount of customers, you really don't need a microservice. A monolithic server can handle all those things. So usually in a production setting, right, in a situation like that, you build a monolithic application first, and as the users grow, and as the users grow, you have an observability. I mean, you obviously, when you build a system, you need to have some sort of observability, logs, metrics, all those things. Through those things, you should be able to understand what are the services that has more like transactions coming in and going out, right? And based on that, you can break that service monolithic into two. So for example, here in this API server, right, let's say we are building this API server as a monolith, right? And we have what, 3 APIs here, right? And this monolith server can obviously horizontally scale, and still each service can serve these 3 APIs, right, to the client. But let's say through observability, and you can scale this as much as you want, right? Let's say you have like ton of, like, a big budget for this application, and you can like spin up like hundreds of servers, scale up to hundreds of servers, and still serve all of these things, right? But through observability, you find out people use this API a lot more than these 2 APIs, right? Let's say if these people post tweets, I mean, obviously people will post tweets more than people than following and following people, right? So let's say, for example, you have a ratio of like maybe 1 to 10, a ratio of people posting tweets than following. So you obviously have more requests coming into this API, right? And what this gonna cause is these 2 APIs will also kind of have a hit. So let's say you have like 6 servers running in, like a lot of requests coming in, and the servers obviously get slowed down, and that will obviously affect to these APIs too. If something gets hung up in a server due to this, it's gonna definitely hit these two APIs too. So in that situation, through logs and observability, you will kind of understand. You can obviously see these kind of things when you have like good observability and good metrics, all those things. It obviously makes sense to put this into its own microservice, this API into its own microservice, and have it so totally decoupled out of these two things. And that way you'll have more resources spent on this, and you can have it probably run like a couple of servers just for these two APIs, which is not going to cost you a lot, right? So that way your cost gets cut down and your performance increases. It's a win-win. So that's think about that when you build a microservice kind of system. Before you, why do you want to go into a microservice kind of systems? And there are more things kind of come into play too, like based on the team. Also, let's say you want to build a whole different team, two different teams based on this. A whole team handles this post tweet service, and another team handles all the follower kind of domain layer. So that time also makes sense to split, but I would more lean into like splitting based on the performance or like the usage of these APIs. So okay, it's like we went on tangent over there. Let's come back to this design, okay? So we'll scale this server horizontally, and this API gateway knows which server based on the load. It'll know, let's say, yeah, maybe layer 4 API load balancer, and so it'll just route the request based on it, and it'll does its thing with the database. And also this is going to have more instance to like horizontally scaled up system too. So basically it'll look like this: multiple services running here, multiple this. It'll have a load balancer of its own. I'm not going to go into details of here. It's going to take the request, balance it to the API gateway that's appropriate to take the request, and that API gateway like basically routes the request to these servers over here, and it makes the request to database. So let's come to the database here. So we know we make 2 billion posts a day, but 2 billion reads per day, and this one single database is going to be a huge bottleneck when it comes to that. So here when you see, it's like 10 to 1 to 10 ratio, right? You have one write for every 10 reads. So we need to have in a situation like this, it's always better to have a read write replica. So the read servers, so the read APIs basically, which is the timeline API, which I'm going to come to that later, gonna hit the database a lot more than this post API, right? So it makes sense to have these things in a separate two databases. So here, let's say we'll have this post API, which is the write database. Let's call it write database. So all these requests gonna come and write to this, and then when we want to read something, we'll go into the replica, okay? So this replica is what does this replica is gonna do? So obviously the person can view the tweet, so that reading will be happening here. It can basically come and read this. That's one way. But instead of that, let's think about this view timeline thing, okay? So what do we need in the view timeline, right? Let's build a database schema for that. Timeline table. So here we'll have a user ID, obviously. The timeline needs to be for one particular user, and this gonna need to have a list of posts, right? So we can also say tweet ID, right? So this timeline basically gonna have user IDs and tweet IDs. What else do we need? So this is gonna have like a list of user IDs. So let's say we have like a user want to see 100 posts. They'll have 100 user IDs of there with the 100 for each tweet they want to see, right? And we can have other metadata too, like created at on all those things. And this needs to be served in a paginated fashion, right? Because the user will scroll down. We don't want to like queue all, like if I have like 100 tweets they want to view, they don't want to see, they're not going to see the 100 tweets in the mobile app or the web app. They're going to just see maybe like first 5 of the tweets, and they want to scroll up. So we need to paginate this data and serve it to the user. Just give me a minute, let me go and have a glass of water. Okay, that felt good. Okay, so basically what this would do is, this read database will have this timeline tweets timeline. I'll get back to how we're gonna have those kind of things here, because it's just a different database here. How are we gonna get that here? But let's say we have this list of things, and this, when a user comes and tries to view the timeline, they'll receive a request to this API with the pagination. The pagination values will be coming from the client side. So for example, the limit and the start of the page, and as the user scrolls down, the start basically increases, and we'll get those information through the API gate from the client, through the API server, and the API server is gonna basically query the database and serve it back. Okay, and how does this database going to have this timeline information? So one nice way to do that is to have another server in between, and we can call it timeline aggregator service. Okay, so what this service is going to do is basically pulls data from this server and builds this timeline data and stores it in this database basically. So this can basically run periodically and pulls data and serve it here too. And we can also maybe have like a messaging system, whenever message gets posted to the database, it's updates the, like produces a message to a Kafka cluster, and that this service basically consumes that message and produces the timeline and updates the timeline and posts it here. Okay, and the API server is gonna basically pull that data into this, right? And here also we need to have a clusters of these aggregators running. Maybe we may need more aggregators than what we have for the other things, because there'll be a lot of tweets getting written into this database, 2 billion database, and there will be 2 billion databases, post reads, and we may need to have like bunch of workers running here, like way more, and have it write to this database. And this also needs to be basically a cluster. Okay, this is not going to be just one instance, it's going to be a cluster too, and this can be a cluster too. Okay, and obviously we can also have a caching layer in front of it, like a Redis cache, in a LRU fashion, least recently used. So let's say we have like so recently viewed tweets are already in the cache, so the API server can easily pull that and serve it. So that's that. And also When it comes to the haven't designed the API. That's also for the view tweets. Let me go and do that as well here. So we'll have a complete design of all the APIs. So that's going to be a GET request. Let's say API. Um, let's call this post, okay? And we can have like query parameters, right? Start equals some value. Say start well, and ampersand, and limit value, right? And in the header we will give these two information, and there's no request body here, and the response body is basically going to be a list of tweets, basically, right? In a simple form, we're gonna have the content. I'm just gonna put content here. It's good to have more data, like metadata, like created at. Created at, posted at, number of likes, retweets, all those information in this object, and we're gonna have like a list of it, basically. Okay, and yeah, and we gonna have this set of response code too. 200 okay with the response body. Something's missing here, we'll send a 400. Missing auth token 401, and something goes wrong in the server backend, we'll say 500. Okay, so like we said, right, based on the based on these discussions, based on these estimations we came up with, we'll have more reads and more writes, right? So in that case, it makes sense to have a different server, because we have this information here. We already know there's more reads going to be. So I'm going to call this server just we can call this let's call this write server. Okay, just to give a different name, let's call it the write server, and let's make some more space here. This set of data, we have the Redis cache, and let's have a cluster of read servers. Okay, just cut this down. Oh, come on, read servers. Okay, and we're gonna need a cluster of that too. But so this read server, this server is basically gonna serve the data here. Any reads data. So whoever requesting the post, this server will take care of it, basically, right? Right, so we're gonna split these set of few APIs in this write server. Is basically gonna write to this database, and the aggregator will pull that data and update this database, build the timeline and update the database. And whoever comes into the when the API requests to view the timeline with the pagination information, this API gateway is gonna route that to this one read server. It's gonna pull that from the check the Redis. If it's not there, pull it from the database. So one way to improve this is, like I said, we'll have a Kafka cluster here. It's going to be a cluster too. So it's basically going to, whenever this server writes it to the database, it produces a message over to this cluster over here. And the timeline aggregator, basically, instead of getting it from the database, it's gonna get it from the cluster here, from Kafka message. It's gonna consume that message produced by the write server, and processes that message and stores in this database cluster. Okay, I think this is a much better design. And also we can have this following, so the follower, unfollow, and posting a tweet, all this server is going to take care of it. And viewing the timeline, this set of cluster is going to take care of it. Okay, so I think this is a pretty good design, system design that can handle it's very easily scalable. There is no single point of failure. Yeah, and we in terms of database, I would say for our use case, um, relational database fits nicely here. I don't see a need for NoSQL database here, but SQL database will nicely fit in this kind of domain, and this kind of data that we need here. So yeah, so this is the Twitter system design. If you guys like, and if you guys have any questions, please post a comment right below, and please like this video and share it with your friends. Yeah, I'll see you with another system design run through with you guys. And if you guys want me to do a system design for a specific domain, or for a product that you guys like, I can definitely come up with the design and walk you through it. And thank you so much for watching, and see you guys in the next video. Bye bye.